Hello, 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 and welcome back to yet again another Turning Tuesday video from none other than the polar North Dakota, where we've got an amazing 4+ inches of snow outside. And if you're new here, I want to first say thank you and welcome to our YouTube channel. GitCAD Cam here, as well as myself, Fusion Phil. We are an Autodesk partner. We not only can sell Autodesk Fusion software, but we can also implement things like training, post-processor development, and ongoing support. And that is why we have been requested to slow things down when it comes to our Turning Tuesday videos, as well as our Milling Monday videos, as we walk through the different areas of Fusion, building out some scenarios you guys may or may not be used to, as well, different tricks along the way and ways to increase, actually make your workflow better and decrease your cycle times and programming times. So this week, we're going to jump into this. We are doing our tool library for our lathe. Now, if you're looking for the mill version of this course, we went ahead and did that yesterday, and that is on our YouTube channel. So I'm going to start sharing my screen here. Looks like you guys should be able to hear me and see me all right. Now, as a request that did come up, somebody was curious, where do I get my models from? I failed to realize that I should have showed you guys physically where those are. So you're going to want to make sure you're on the home tab looking at all of your projects in your team. And you're going to scroll down to the bottom where we have what's called CAM samples. And then in those CAM samples, you're going to find a lot of different part models to work with to include this quick release hub. That is actually where is it in here? It should be in here somewhere down here at the bottom, 2x turning quick release. So feel free to use these models throughout our next several weeks as we dive deeper and deeper into Fusion and walk through anything and everything. So the first thing I'm going to do is I'm going to go ahead and open up my tool library. Now, I am going to tell you guys, actually, I'm going to pause real quick. First thing I'm going to tell you guys is we need to change some of our preferences, but I also want to let you know that if you're watching this live right now and you have any questions, feel free to leave a comment down below in this video or use the live chat so that we can answer those in real time. Now, you could also use our email link for additional support if you're watching this at a later. So let's go ahead and set our preferences. Now, I'm going to go up to my actual profile here, top right corner of my screen, and we're going to go to preferences. And then in here, we're going to expand out general, and then we're going to look for the tab called manufacture. This is where you need to enable your cloud libraries. I highly recommend this. Again, with the jump from Windows 10 to Windows 11 happening right now, a lot of people are asking us about why their Toolpath or their tools have all disappeared. And it's because they never saved them to the cloud, and we'll see that here in a moment. We also over here at GitCAD Cam highly recommend that you toggle on everything under the browser display properties all the way down to the bottom where you can see the word prompt. Again, as we progress over the next couple of weeks, this is going to give you more and more detail on your toolpaths, making your life much better at the end of the day. So once you go ahead and check all those boxes, again, to include cloud libraries, we're going to go ahead and hit apply and OK. So from here, we do need to make sure that we are, of course, in our manufacturer workspace. And in our manufacturer workspace is where we can actually start to look at our tool libraries. So if we go over across to the top, now it does not matter if you're in the milling tab or if you're in the turning tab or any additional tab. What we're looking for is our manage dropdown. And from there, we're going to go ahead and grab our tool library. So by default, again, I cannot stress this enough. I also see Blah Blah out there. Great to see you back once again, Blah Blah. But on the left side of my screen, I have my different locations for storing tools. As we discussed yesterday in our class, we can actually look at the different tools that are based on our document. Now, you guys are seeing we do have certain tools already on this file while they're pulling up. You should also see one labeled cloud. Now, again, I cannot stress this enough. Please make sure this is turned on. If it's not turned on, rewind this video about 3 minutes and see how to turn it on. This is very, very important because this is where we can do things like right-click and import our libraries so that we have them on any computer that we're accessing Fusion from. We could also do things like new folders and new libraries. As you guys can see, I've created a folder for a shop crib. Then I went ahead and stuck something like a TL1 in here. Again, the idea is the more organized you can tend to be right now, the better things are going to get as we start to program our parts out. Continuing on down a little bit further, I am going to minimize these as we go. But as you guys can see, we now have the local library, which is, I'm going to say, is the no-no library. Do not put things in your local library, please. Again, this will help you a ton in the long stream of things. Again, we have a Fusion library, which is where we can pull a lot of default tooling from. And as you guys can see, we have turning tools by default. Pro tip here, when you guys put in support tickets to me, there's a problem with your toolpath. A lot of times I just go grab a default tool. It tends to work. So again, great starting point to pick something already built and convert it. Moving on a little bit further, now mainly for the milling side of things, you do have vendor tools inside of Fusion. However, this is where I can transition over to the right side of my screen, and we can make a decision on what kind of toolpath are we doing. So if I go ahead and click turning, as you guys can see, I actually have a ton of turning tools in here. It's a little bit of a shock to me, but it looks like these are pretty standard tools at the end of the day. Again, nothing too fancy as you're seeing. The nice thing about the filters is when you build out your library, you could quickly then narrow down to boring tools only. For this demonstration, I'm going to go back to the Fusion library just to show you how that works. Maybe you're doing some grooving, so forth and so on. Again, the key element here is when building out your tool libraries, we're going to build some tools here, but we want to make sure that we're always staying as organized as possible. Again, I'm going to move back over to the shop crib, or in this case, the cloud, I should say, where I've created the shop crib. And for demonstration purposes, I'm going to go ahead and create a brand new library. And let's say I am going to call this the ST20Y, right? Pretty easy Haas machine. As you can see, I've now made a library here. This would allow me to copy tools over, possibly build tools out specific for that machine. As I like to do is whatever's in the turret at the end of the day from my document. So again, as you guys can see, I can go back up to my quick release hub and I need to clear my filters, of course. But if I was done with the tools on that specific part or model, I would go ahead and just highlight copy and then paste them into my tool library for that machine. Again, allowing me to grab those, move on to my next part very quickly, and already know what's in that turret. So from here, what I'm going to do is let's build out our first tool. So again, it is very easy to grab a pre-built tool, but I'm going to go ahead and start by building a tool this time around. As you guys can see, I hit the little plus inside of Fusion. As you can see, I can pick my turning tool. So we're going to do nothing more than a general turning. And from there, we could start to give this a description and give it product information. Now, I'm going to say this is just a CNMG tool. And from there, we're going to jump over to our insert. Again, we do have the ANSI code. So if you were to go in and say CNMG, for example, it's not going to recognize that code. It's okay. But in some of your tooling, as you will see, it will automatically update and grab the information as we go down this list. So again, CNMG 36, as you can see, it's now populated CNMG, insert size, thickness, and so forth and so on. Now, if you're trying to do something a little more custom, as you can see, is you can go through and you could define these manually as well. In this case, let's just say we have a, let's go with a V. So we're going to get a much more diamond profile tool. Again, we can have a relief angle. So again, you can see there's an backside relief angle. Most inserts have them. So we'll say about 5 degrees. Our tolerance, again, based on your information for your inserts. Again, I don't want to bore you guys to death with this, but as you're seeing, we can go as far as even the number of insert for the tooltip on our specific insert. From there, we're going to go ahead and swap out because this is where, in the event you pick the wrong tool, we could easily change over to boring, grooving, or threading. We could also define, again, if you're working in, as I heard it called, freedom units or the metric system. And lastly, what is that insert actually made out of? Most times nowadays, it's carbide. Carbide inserts are pretty dirt cheap. However, if you're still using high-speed steel and grinding your own inserts, which I do know how to do, one of the great tricks that the Marine Corps has taught me is we could go in and define that as well. So as you're seeing, I didn't touch on this, but everything in Fusion tends to be a left to right, top to bottom workflow. We're done with this row of information. I'm going to go ahead and click on my holder and basically repeat the process working down this list. As you can see, this is a left-handed tool. Well, I may actually want actually not a left-handed tool yet. This is based on what kind of relief angle we actually have on our insert. Again, if we go to a 0 style holder, again, my insert is changed out in this case. However, you can change these to whatever you are needed to get that profile that you need for your tool. Same thing would happen as if we went from a left to a right-handed tool. If you guys didn't know, with the insert facing up, when you go ahead and grab that tool with your hand like a handshake, if the insert is up and you're handshaking with your right hand, the right-handed tool. Again, you could even go to a neutral tool, getting you on center of that actual holder. Not very common. Now, there is a time and place for this. Most of you are always going to work with a right-handed tool. Another pro tip here, guys, if you have a sub spindle, you could still run right-handed tools in the sub spindle. And I'll show you how and why that matters. So again, this is what I personally love about defining the tools inside of Fusion. Every time we click on a menu, as you guys see, I get this blue little menu that pops up. What is the cutting width? Now that is the tip of the insert from the back side of the tool holder. We have things like the head length. And again, moving down to overall length, shank size. And then lastly, if you needed a round shank, we could always turn on a round shank. And again, then you have one dimension and one dimension only. So again, we transition over to our setup. Now this setup is something new at the end of the day. And why it's new is because depending on which way you click or which item you click determines insert up, insert down. However, we're pointing X negative. If we move over to the back side, insert up, pointing Z negative, so forth and so on. So I'm not going to be the one to say that Fusion can handle twin turret machines at the moment. There's a lot we can do with a lower turret. It's not fully integrated. But if you have tooling that is on the lower turret, as you guys can see, we could define that tool there. Another good valuable one is maybe you have a gang style holder. So again, the orientation of the tool in the holder is very, very important. I do want to get back to that idea that if we were talking about the sub spindle, like I told you guys, this is a right-handed tool going insert down to insert up, and we could go run it on the sub spindle. To save yourself a little bit of money, you don't need left hand and right hand tools in most cases. There's a time and place. So we're going to stay with the standard insert down, as you guys can see. And then from there, we could always flip it. Again, not a big deal. As you're seeing, the flip option here is pretty much obsolete since you can go ahead and click that in the, what I will call is the clock of orientation. So again, as we're looking, we can move on to our compensation point. Now, this is something that is very, very important, but also not very important at the same time. If I zoom in on the very tip of my tool right now, as you guys can see, is tip tangent means we are tangent on the actual radius of our cutter. For most of you, you touch off your tool maybe in the X diameter and you do a X diameter set. Then you touch off in the Z axis on a part, and then you set your Z axis for your. Now, those of you with a presetter, it could be a little bit more different than this. However, you're probably lucky with an automated system that still uses tip tangent. Now, if I go ahead and swap this out, we have some other options. One is insert center. Again, the screw, I'm going to go ahead and flip my tool the other way. Basically, the screw that holds that insert is where our compensation comes from. Not common. There is a time and a place for this. But again, we can adjust these things dependent on what it is that you're trying to do. Again, tip is based on coming off of our two angles, not tangent anymore, technically still tangent to the radius, but I don't want you guys to think like that. But we are out at an extended point in space where the two flats of that insert come to meet. Again, we could go down to tip center. Now this is the center of the nose radius. And I think some of you are starting to realize that maybe your parts were out of spec or not performed correctly because of some of these settings. Every machine is different. I will say if you're working on a B-axis style lathe, you may need some of these settings. If you're working with a lathe that can do a lot more out of the box than a good old-fashioned tool room lathe, some of those options will be very valuable. Overall, most of you out there, tip tangent is going to do what you need it. Now, again, we do have our spindle rotation, whether we're going to go clockwise or counterclockwise. A lot of people get caught up in this, but I am going to show you guys that they have changed some things around to make your life much easier on this. So let's go ahead and get back into our original orientation of insert down. Our part would actually need to spin counterclockwise. However, we're not going to check this box at this moment. In the event we get our G code backwards, we can always come back and fix that. So let's move on to cutting data. Now, cutting data is extremely important. I would say personally, you can get away with a lot of things here by maybe defining the wrong insert, but because we're doing tip tangent, you're in pretty good shape. Now, from that, the holder does make a difference, but again, unless you're working in really tight confined spaces, not really needed to the extent of one, being orientated the right way, but two, your speeds and feeds when it comes to these. So let's talk about our speeds and feeds. Again, that left to right kind of workflow applies here because we have two columns of information. Now, column one is basically your preset. So what I like to do is I like to set my presets in a couple of different ways. Now, we did this on milling, is I like to personally either tell it what machine this tool speed and feed is for, or maybe a max RPM type of situation. Now, that could range from a lot of different things. Let's say this is going on my ST20Y. Now, you could plug in more information after that. So we could now say this is for, I'm going to pick on aluminum. I like picking on aluminum because it's the times where you see outrageous surface feet per minute. And then maybe I finish that off with an R for roughing, right? So on my ST25Y, this is my 6061 roughing. Some of you are probably questioning my choices right now because that's more of a finishing insert. It's okay, guys. The walkthrough here is to build out the tool and get your data into the system. But from here, we can go ahead and plug in our information. What is our surface feet per minute? Let's just go ahead and say it's a clean 650. From there, you have things like constant surface feet. If your machine does not support this, we can uncheck this box, which would allow for the post processor to output without constant surface feet. Again, we can go down to our feed by rev, or you can use inches per minute. More common than not, if you're looking at your tool vendor information, they're going to give it in feed per rev or feed per tooth if you're a mill guy. It all adds up to the same. We're going to go ahead and swap this out to about an 8 thou load. And from there, the last piece of information we're going to do is we're going to give this a depth of cut. Now, again, we are fronting and prepping things here so that when we pick tool paths in the coming weeks, this information will auto-populate. And I'll show that to you. So let's say, for example, I can get away with about a 55 thou depth of cut. And again, depending on your machine, your configuration of your turret, some machines do have through tool. Again, that might push up through a little insert on the tool holder, more common in your boring bars. But again, you guys can adjust your coolant codes. Now, I'm going to run this through one more scenario because I really want to make the point clear to everybody that if you hit the plus sign here, we could start another one. So let's say we're going to be on a TL2, and this is going to be 6061. Again, we're going to stick with roughing, right? But as you guys can see, I can now go back. Maybe the surface feet on that machine is a little less. Maybe I need to take a little smaller depth of cut. We're going to run it closer to 450. Maybe we're doing about a 5 thou chip load. And then lastly, my depth of cut on that machine, it doesn't like anything past about 25 thou. I am now quickly creating presets for this tool to grab on the fly when we get to programming our parts. So again, we've kind of wrapped everything up here. Now, I'm not one to recommend plugging in every single speed and feed in every single use case. As you go on, you're going to add more and more to them. So we're going to go ahead and jump over to post processor now, because I feel like this is very, very important and it is very dependent on the machine running. So, option number one, you have what's referred to as your tool number. Now, on most machines, that's also considered a pocket number. And the reason why I say that, again, is if I had a turret with 20 stations, we'll use stations versus pockets, but you could have multiple tools hanging out in that same station. So, for example, let's say this is in tool 10 or station 10. Well, with that being said, I might be using the back side of that station for the subspindle. Again, if we get in here and start flipping around our tool, we could go through and we could say maybe it's going to use offset 110. So again, station 10, pocket 10, however you want to define that, turned around and accommodating a compensation offset specifically for the subspindle. Again, this gets into when we're double stacking tools and things of that nature. So as you guys can see here, the last thing we do have is the ability to control stuff with turret numbers. Now, I'll dive into this a little bit more, but you could have an upper turret or a lower turret, or in the event that you're dealing with a gang-styled holder, this is where we need to use a turret number to post out whether or not our tool is moving X positive or X negative, and so forth with the Z axis. But I'm going to go ahead and plug this back in. This is just going to be tool 10, pocket 10, nothing crazy here. And we're going to go ahead and hit OK. Now, the key element here is when we start to make our tool paths is that we're pulling tools from a known location. Because in the event I ever have to update my speeds and feeds because we put a different insert in that tool, I could easily edit that tool in my main library. I'm going to go down. I'm going to add another one in. Now, this is, again, this is up to you guys, is I might use maybe the insert hardness. Maybe it's an IC 900 insert roughness or 4140. And then we're going to say that's pre-hardened. As you guys can see, you can label these out any way that you like to make your life easy when it comes to grabbing that information. Maybe we slow her down to about 150, calling out, about 8/10 chip load. And again, maybe we could take a much bigger depth of cut, not 1 inch. Please do not take 1 inch depth of cut. But as you're seeing, it's very easy to add in these different speeds and feeds for your tools. Now, speeding this up a little bit, it all comes back to the same. It doesn't really matter which holder you grab. Again, I'm going to go now back over to my thread or turning thread profile. Let's just say this is for a 20 PPI, threads per inch. I go to my insert. Again, you're going to go through and define all your different information. One thing to really keep in mind, though, is you have what's called a minimum and a maximum thread pitch that's allowed. So again, I could type in here, not 20 divided by 1, 1 divided by 20. And as you'll see, I will get my 50 threads per inch. So again, we're going to go ahead and plug in that 50 down here. And now you can see this is what I love about Fusion. It's what makes it so easy to teach is when you go through and you start to plug in your information, even if it's wrong information, it'll notify you when it is wrong information, right? As you guys can see, it told me that this needs to be bigger than that. And just like that, we've gone through and figured that out. Now, if you're somebody dealing with something that might be a little bit more of like an Acme thread or a little custom profile, you can get pretty creative here. However, you're not going to get a 1-to-1 ratio when it comes to the differences across the tools. You do see up here at the top, I can go for a rectangle versus triangle profile, but I can't simply say that this is Acme thread. Now, that doesn't necessarily matter when you run it on the machine. When you run it in simulation, you will see the difference. So again, we jump over to our holder. As you can see, we're just going to go with the standard outside holder. Setup direction is still the same again. We even have our cutting data. Again, ability to set, in this case, just an RPM because our feed rate is determined by our thread pitch. Lastly, we have our post process. Again, guys, if you wanted to go in, plug this into, maybe it's in 8, and we're going to go ahead and leave that as 8 also for compensation. Now, some of you will ask about what is brake control. Well, brake control, again, is if you have a presetter you have the ability to use it, we could go check a tool when you're done running. Going back to the 4140 days, you could be blowing out inserts after, 10, 11 parts, but they show wear up until that point. We could go check that tool at the end of its cycle. So as you're seeing, it is relatively easy to build out tools when it comes to the lathe profile. Now, I want to show you real quick before we pivot over to drilling and tapping. But as you're going to see here is if I go in, and if you didn't catch any of my other content last week where we did setups, I'm going to do this relatively quick because it's not going to be anything overly important. I just need to get a toolpath on my part. And as you guys can see now, we can go out and select our tool. I could go to my TL1 or my ST20 area. I grab that tool. This is the material I'm running. And just like that, we've now created our first and very most toolpath. Now, this does go a little bit further than this because you can override this type of information on the fly. But as you're seeing, I can actually go forward or reverse my spindle direction right here in real time as well. So this is why that checkbox for clockwise versus counterclockwise is nice. But then in the event that I need to reverse my spindle for some reason based on my insert direction, we could do that in real time. Another thing I will tell you guys is in the event you do have a B-axis head, this is where you can come in and you can set an angle to your tool. So if I wanted my B-axis to be tilted at 45, again, that is all controllable based on your post processor, of course, guys. And if you need custom posts, feel free to reach out to us. I'm just showing it to you here to see how that is set. Lastly, we could always switch out our presets too on the fly. Maybe I forgot that this is actually aluminum. And just like that, I'm not only pulling out my tool, but I'm able to control additional things that most people don't realize when it comes down to fancier and more advanced equipment. Now, what I'm referring to when we start to talk about gang style tool holders is if I was to go out and pick a Fanuc turning post, for example, and if I hit this edit button, what you're going to notice is some posts have additional information in them. And that information is use turret 0 for positional turret, use turret 101, 102, yada, yada, yada. And then you have your gang style tool holders as well. So again, you could, in theory, turret 101 could be on the X negative side. Turret 102 could be on X positive side. Again, with your tool room mills, we start to talk about gang style tool holders, but pretty straightforward that this is in most of the post processors that have the ability to do it. Again, guys, please reach out to us if you need help with posts. We're here to help out in any way we can. So let's go back. We're going to shift things around a little bit. And how we're going to do this is we're going to go back into our tool library. And this time I am going to build out some actual drills and taps and possibly center drills. Now, the process is still the same. We hit the plus sign. This time, we're actually going to work in the hole making area. Now, some people do confuse this because it does say boring bar. This is for mill boring, not turn boring. So from that, we're going to start off with something simple like a spot drill. I like using the spot drill. It's a pretty good example of a couple of different scenarios. Again, maybe this is going to be a 1/2 inch spot drill. From there, we go to our cutter. We define everything about that. Carbide, hopefully, unless you're dealing with a high-speed steel cheapo from good old MasterCard to make the weekend deal. We plug in our OD diameter. My tip angle in this case, I'm going to go 90 degrees on it. And as you guys walk through this, again, you have the ability to define the stick out, shoulder length, flute length, things of that nature. Now, on a lathe, it's not important. You really don't have a gauge length. Now, if you're dealing, again, with something with a B-axis milling style head, gauge length can be your best friend. Getting into a shaft, this won't apply to most of you guys on the lathe. It would be an extension from a mill style holder. Again, not necessarily needed, but this is why I like to show this is because let's say, for example, this is going to sit in like a ER16 holder, something like that, that you can quickly mount and demount from your actual machine. And then you could build, again, a couple of custom smaller ones as well. Now, I'm going to remove this for demonstration purposes because I want to get to cutting data where we can do two things here. The one would be is we would like to relabel this as maybe 60, 61, and then this is spot drilling. And then I can turn around and create a second one, which would be 60, 61 chamfery. Now, more commonly on your mill turn machines, live tool lathes, you are going to need to set something for spot drilling. And then you're going to need that same tool possibly for chamfering edges using like XC programming, things of that nature. So we can now go through and we can make our life easy because we could actually take the spot drilling one and you can set your speeds and feeds to 0, I believe, unless they changed it recently. But the idea is that you're never going to use the spot drill for milling. You're only going to do it for spotting. Again, that's all controlled now down in your retract plunge rates. I'm going to go ahead and plug in the number 1 so we could just get rid of these errors. But again, your actual feeds and speeds for drilling will be determined by vertical feed rates. Now, on the chamfering side of things, this is where we do need our feed rates to go in, mill around our part, things like that. Lastly, we do have our post-processing side of things, and this is very, very important that, again, you now have a number, or as we said, a turret location. You have a length and diameter offset. So we do have to be aware, are we pointed towards the main spindle or the sub spindle? Do we run this with, number 111, or do you guys use a system? You could steal this from me, is you just go up 100 if your machine will take it, and go 101, 101 for the sub spindle. Again, this is all stuff that we do in our training classes and we work through our support packages to help you guys understand better. And in this case, do we need a turret number? I don't think so. We're just going to keep this standard. What I really want you guys to get down and look at is there's an option for what is referred to as live tooling. So this is very, very important because if this is hard mounted in the turret, meaning the part spins, your chuck, we need to uncheck this box. If this is in a live tool holder, then we need to make sure that this is checked at the end of the day. Now, you notice that this tool is not orientated, and the reason why it's not orientated is in the world of Fusion. Mill tools always come in on the Z-axis, and that's where we have things like the ability that, again, a little foreshadowing here is we can tool orientate mill tooling, which includes drilling, so that we can come in on that Z-axis. So again, let's do this one more time. I'm going to go ahead and jump back over. We're going to go back to our tool library. Again, let's make one more tool here, and this time around, we're going to go ahead and do a tap. Again, very common on a tap. We're going to go ahead and set our cutter. Maybe our thread pitch is 50 still because we're working with that quarter 20, 250 diameter. Pretty straightforward information that I'm plugging in. I'm going to jump over to my cutting data. As you can see, because we're dealing with a tap, just like when we were dealing with a threading tool, we would set a max spindle speed, and it would use our thread pitch to set our feed rate. Lastly, in our post-processor tab, again, very, very important. Maybe this is a stationary tool, so we're going to go ahead and uncheck live tool. And again, you could plug in any information around that tool. So as you guys can see, this is how we kind of build out our tool library. We have our tools now easily accessible for anything you may need to do. Again, controlling our tool numbers at the tool level. And in this case, we've stored a lot of these at our machine level. So as you guys saw me do when I went in and I picked that tool for my operation, I'm always pulling from the standard area. Now, again, if I wanted to see all tools in my library and filter down throughout the day, you could see I can quickly go through and filter out to any and every tool that I have and even see what individual area those are sitting in. So again, I'm going to go ahead and pause for a moment. Does anybody have any questions before I go ahead and wrap this all up? Going once, going twice? Well, I appreciate all of you guys coming out and checking out this new content. If you don't mind, leave a comment down below. Don't forget to like, subscribe, get notifications as we kick off more and more down in the nitty-gritty of each area of Fusion, what it does, how it works, what kind of actual application can you expect out of it, and where's the best use case for most of it. So with that, I'm going to leave you guys to it. But as you guys know, it's not what you know, it's who you know. You all know Fusion Phil over here at JetCAD Cam. Feel free to reach out to us anytime with your questions. And I look forward to seeing you guys back here tomorrow, where we're going to show off the Autodesk Fusion machine connector that allows for quite a bit of cool things, especially like sending code to the machine, monitoring when the machine is running, when it's not, as well as how easy it is to actually set up and get going. But other than that, if you want to skip out on that, I hope to see you guys all on Friday with another Free Support Friday kicking off at noon Eastern Standard Time. So thanks, guys. Have a great rest of your day. Get back to it and let me know if any of this was helpful. Thanks.